Hello everyone, I am Sri Prakash, Research Scholar, Department of Electrical Engineering, IIT Varanasi. Okay, wait for just a minute. I will start for today's session. Okay, let's start for today's session. There are some questions from previous class. I want to solve that question. First question. After that, I will start for APM network question. We also to put network, consider the below circuit. The maximum power transfer to the load resistance RLH. There is a two-port network between source and load. They are asking about the maximum power transfer to the load. In the condition of maximum power transfer is simply RL should be same as the source resistance. Load resistance are equal to the source resistance. But here you can't be say exactly what is the source resistance in this network. Then how can you find the maximum power? The parameter is given known as the impedance parameter, Z parameter is there. It means there is a circuit between them, and the circuit behaving like a impedance is there and bidirectional circuit, and then after you transfer the energy from through that circuit after that the load. You know about the Z parameter. There are two equations, V1 and V2. This one Z11 I1 plus Z12 I2, Z21 I1 plus Z22 I2. There are two equations given. Z11, Z12 value is given as Z11 is 5, Z12 is 2, and Z21 is 3, and Z22 is 6. But there is not defined the circuit. To solve these type of questions, you have to define these quantities. Okay, how kind of write these equations in your own way? Suppose this is the Z11. Z11 is simply I write it Z11 is simply V1 by I1. It means this is the impedance. Okay, but V1 is equal to Z12 into I2 is there. This is the voltage equation. It means this all are denoted as the voltage. This is also a voltage because of this equation is the voltage equation. It means there is a voltage drop here, and this is the secondary side parameter is here. It means you can say this is a current source. A voltage source depend on the current. Can also says like that. Okay. Simply I want to draw this circuit. Suppose there is a two network. V1 is here and I1 current flowing through it. Then for the V1 equations, there are impedance directly in input side known as the Z11. You can add a impedance like Z11. Then after there is a impedance and a current. Which one current is secondary side current? Suppose this is a V2 and I2. This current is transferred to the primary side. Then you can say this whole part is the voltage. And you have to define a voltage like that, and this voltage depending on the current of I2. Then you can say this is a dependent voltage source which are known as Z1 to I2. Okay, if you apply the KVL here, then you will get the V1 is equal to Z11 I1 plus Z12 I2. First equation is completed. Then after second equation is simply V2 and I22. It means there is another impedance is there Z22. Then after voltage source, which one is depending on the primary side current. Now Z21 I1. So we have to simply connect this like that. This is a circuit. You don't define the Z parameter. Simply apply KVL here and KVL here. We will get the two equation V1 and V2. V1 is equal to Z11 I1 plus Z12 I2 here. Simply V2 is equal to Z11 Z22 I2 plus Z21 I1. Simply that equation. Okay. This type of equation, if you define that equation like that in this form, then you can solve the all question related to this is in easy method. Okay. There are two resistance there, another resistance, 1 ohm resistor, and this is the load resistor. Simply I can add these two in this circuit like that, and this is the voltage source 10 volt, and there is a load resistor RL. Okay. You know about to find the maximum power transferred, or to apply the maximum power transfer theorem in dependent source circuit, then you need a Thevenin equivalent circuit like VTH and RTH. You have to find the VTH and RTH of this circuit. Then after you simply apply the MPPT theorem. It means this circuit you have to convert in a voltage source and a resistor. This is the VTH, this is the RTH, and this is the load resistor RL. And in this case, for the maximum power, you know RL is equal to RTH, and P max is equal to V square upon 4 RL. Simply you can apply this one. But before this one, you have to convert this circuit into this form. It means you have to find the Thevenin equivalent circuit of this circuit. Okay. Independent sources, for finding the equivalent circuit, simply you have to remove this load resistor and apply VI method. Okay. This is 10 volt, 1 ohm. Z11 is given as 5 in this question. 5 ohm. This is Z12 I2. Z12 is 2. It means this is the 2 I2, and this is Z21 I1. Z21 is 3 in this question. It means this is the 3 I1, and Z22, this one Z22 in the question is 6 is given. 6. Okay. Apply KVL in this loop, then after apply KVL in this loop. This 10 volt is equal to this current is I1, and this current, suppose take as the I2, can take this is I2, and same current is flowing through this one also. This one I2, I1 1 ohm and 5 ohm, 1 into I1 plus 5 into I1 plus this one 2i2. That means this is 10 is equal to 6i1 plus 2i2. So this question number first. Again, another one, this one V2. You have to find a voltage V2. This is a 6i2 plus 3i1. Okay. We have to replace I1 in this equation. Then how can we replace? From this one. I1 is equal to 10 minus of 2i2 divided by of 6. Then V2 is equal to 6i2 plus 3. I1 is 10 minus 2i2 divided by of 6. V2 is equal to 6i2. This is a 2 times. Then this will be 5 minus I2. V2 is equal to 5i2 plus 5. And you know about this one, this is the RTH in this method and this is the VTH. Simply you can make a circuit like VTH and RTH, then after you can apply a RL load. VTH is equal to 5 volt, this is RTH is equal to 5 ohm, and this is RL for maximum power. RL is equal to RTH is equal to 5 ohm, and Pmax is equal to VTH square divided by F 4 RL. VTH is 5, 5 square is equal to 25 divided by F 4 into 5. This will be 1.25 watt. This much power is transferred from primary side from the voltage source of 10 volt in this case. Okay, we have to simply make a circuit according to the given equations in the parameter. If this is the voltage equation, it means all of this is the voltages. If suppose this is the current equation I2 and something is there, it means all the component is the current equation, not a voltage in that case. But for the impedance parameter, this is the voltage, it means all this component is voltage component. You have to make a circuit like this. Once the circuit is completed, then simply apply the KVL KCL. You will get the final answer. Next question. Here the short circuit admittance parameter of the two-port network is given as 4 minus of 6 minus 6 to S. Then given as the input admittance seen from the terminal AB is. It means you have to find the input admittance. Admittance is the reversible of the impedance. Input side, it means V1 I1 is the impedance of Z1. Then if you reverse this one I1 V1, this is the admittance. You can say Y11 also, because of the this is the Y parameter is given the question. Y parameter, you know about this one. is the current equations I1 and I2 between the V2 and V1. So y11 V1 plus y12 V2. This is y21 V1 plus y22 V2. Okay, all the values given. Y11 is 4. The question, this is the 4. Y12 is minus of 6. Y21 is minus of 6. Y22 is equal to 2. In this case, same, you have to make a circuit for these two equations. The negative part is common to all. Then this is current I1, V1, same here, I2, V2. Okay, we have to make circuit between them. Is the admittance, it means multiplication of y11 into v1. In what the cases is, the current is the multiplication of something into voltage. It means this is the admittance. You can say this is the v1 upon z11. This is the current. Okay, but in 1 by z11 you can say this is the y11. This one is given in the question. That's why simply this is the circuit of current is divided into two part. Current is divided into two part. It means there is the parallel path. And admittance of y11. This is directly connected to the v1, and another is the dependent source of v2 dependent. Then this is dependent, but what is the voltage source and current source? Because of this equation is the current source equation, current equation. That's why this is the current source, dependent current source. So dependent on v2. Is the y1, 2 and v2. Same thing for the second equation I2. Current is a sum of two current. It means the both are connected in parallel. Z22, Y22 connected in parallel to V2. This one, and that one is the dependent current source. Which one dependent on the V1, Y21 and V1. This is the equation. Circuit for the admittance parameter. Okay, then our network is completed. This one. After that, there is some another impedance is also admittance is also given as 4s, and asking about this parameter is I1 by V1 here. Then you have to add here a admittance of 4s. Okay, it means the circuit will be V1, I1. This is y11. Y11 is given as 4. The question 4s. I simply write a 4. This is the looks like a 5, that's why I just written as only 4. Current source is y12 into v2. Y12 is minus of 6 v2. So minus of 6 v2. Same thing here. I2 y22 is 2 and y21 is minus 6 v1. Okay, and another admittance is 4. This is the voltage v2. Simply we have to then apply a KVL KCL to find this. Okay, port one side KCL. What is the I1 in this case? Simply same to same, 4 v1. This is the negative, minus of 6 v2. Same KCL at port 2 side. This current is coming n divided into two part. There is the same equation. I2 is equal to 2 v2 minus of 6 v1. Okay, but what is the v2 in this case? Current is flowing entering in negative side of the wheel. So you can say v2 is equal to minus of I2 into 4. Why 4? Because of 4 is the admittance. Impedance is 1 by 4. Okay, that's why I2 by 4 is here. This is not the impedance, this is the admittance. If there is an impedance, then simply we have to multiply up 4 I2. But this is the admittance, that's why I2 by 4. You have to find the I1 and V1. To replace I1, V1, to find the, we have to replace the V2 in this case. For V2 is the I2. Then we can find uh, I2 in this case and put the value I2 here and find the voltage of V2 in terms of V1. What is the I2 in this case? I2 is minus of 4 V2. Put the value I2 here, minus of 4 V2 is equal to 2 V2 minus of 6 V1. This is the minus of 6 V2 is equal to minus of 6 V1. It means you can say V1 is equal to V2. Put the value here, I1 is equal to 4 V1 minus of 6. V1 is same as the V2, that's why it is also V1. Then I1 by V1 is equal to Y11 is equal to 4 minus 6 is equal to minus of 2. S is the symbol of admittance. This is the answer of this question. Okay. And write this thing here. Simply circuit given as two-port network is there. The simply admittance matrix, you know the equation. From this equation, you have to draw a circuit as your own circuit like that. Then after this if a circuit is there, then you can apply everything KVL, KCL and find the final answer which one is asking in the question. For this type of question, this is the very simplest method to find the answer. Okay, let's try another question also in this basis of this one. A Z parameter of the network N are given as 60, 40, 40 and 70. Then a 10 ohm of resistance is added at the output input. Then asking about the ABCD parameter of the network P, whole network. After adding a 10 ohm, what is the ABCD parameter? First of all, Z parameter. Z parameter is between a V1 and V2. The equations Z11 I1 plus Z12 I2 Z21 I1 plus Z22 I2, and the other parameter is ABCD parameter or transmission parameter. Transmission parameter, you know this equation between I1 V1 and I1, V1 and I1. This is the A V2 plus B I2 C V2 plus D I2. Okay. But in the case the current is opposite in ABCD parameter transmission parameter, we transferred power from primary side to secondary side. That's why this will be negative. Okay, but first of all, find this one total network. Z parameter is given. Equation is this one. And from this equation, first of all, find the circuit. Same circuit as a previous one. Negative part is common to all. In V2, V2. Positive part, this one is a Z11. That's why. Then after a voltage source, Z1, 2 depending on the secondary side voltage. I1, V1, same thing as the secondary side. Current is I2, have some impedance Z22, then have some voltage Z21, V1. Oh, sorry, not V1, I1. Sorry, I2 here and I1 here. This equation is I2 and I2, I1, I2. The voltage equations. You can apply KVL, KCL here. In this two loop, we will get the same equation. Okay, but in the question, some another resistance is adding as 10 ohm. Then after the final equation, you have to find this parameter. Okay, I taken as in this final equation. This is the V2. Voltage is same because of the parallel connection, but current is different. I have to write this is the I2 in our case, and this is the taken as the I2 dash. Okay. In this case, you can say I2 is equal to I2 dash this current plus this current. This I2 is divided into two part, I over 2 dash, and this current is V2 by 10 because of the resistance is given. You can say this is question number first. All parameter is given. Z11 is given as 60 ohm. You can put the value. This is the 60 ohm. Z12 Z12 is given as 40 ohm. It means this is the 40 I2. Z21 Z21 is also 40 ohm. Z21 is 40. This is I1, and Z22 is 70 ohm. Then this side KPL V1 is equal to 60 I1 plus 40 I2. This is I2 dash. It means this is also I2 dash because of the this is a transfer of only this parameter. This is the additional parameter. That's why this whole thing is depending on this parameter only. Okay, that's why this is also I2 dash. This is I2 dash, then this is also I2 dash. Then you can say V1 is equal to 60 I1 plus 40. In place of I2 dash, we simply replace this is the I2 minus of V2 by 10. Then V1 is equal to 60 I1 plus 40 I2 minus 4 V2. So equation number first. Same you can apply a KVL in this loop. Loop sec 2. This is loop 1. And what is the V2? V2 is 70 I2 dash plus 40 I1. In place of I2 dash, you can replace 70 I2 dash is I2 minus of V2 by 10 plus 40 I1. V2 is equal to 70 I2 minus 7 V2 plus 40 I1. Okay. Bus ABCD parameter is between V1 is V2 and I2, and we have to find V1 in terms of V2 and I2. V1 is I1 is there. We have to replace this I1 from this one. Then what? This is 7 V2. We can add this one 8 V2 here. Then what is the I1? In this case, this is the 8 V2 is equal to 70 I2 plus 40 I1. And what is the I1 in this case? 8 V2 minus of 70 I2 by 40. You can replace I1 here, and this is the V1 is equal to 60 by 40, 8 V2 minus of 70 I2 plus 40 I2 minus of 4 V2. You can cut this 0 to 0. This is 3, this is 2, 3 by 2. Then V1 is equal to 24 by 2 V2 minus 210 by 2 I2 plus 40 I2 minus of 4 V2. V1 will be, this is the 24 by 2 is 12 minus of 4, this is the 8 V2. 210, 210, it means 105, half a 105 minus plus of 40, minus 105 plus 40 is equal to minus of 65. I2, equation number third. Okay, V1 is coming from in the term of V2 and I2. You have to find the I1 in terms of V1, 2 and I2. Then what is the I1? I1 already find here, 8 by 40, it means this is the 1 by 5 V2 minus 7 by 4 I2. From these two equations you can say ABCD parameter is, this is the 8 is minus of 65, this is 1 by 5 minus of 7 by 4. Actually this is the positive in terms of this one, because of the equation is negative, because this is the negative current is flowing, but in the ABCD parameter the current of transmission is transmit the power from primary side to secondary side, like the current is flowing like that. That's why this I2 will be reverse. That's why given in the equation is negative. This will be the then positive. V1, D and B. Okay. Then another question is here also. This is the last question in terms of two-port network. H parameter of a two-port network shown in figure are H11, H22. Yeah, someone is Puspak. Have you some doubt?
Yes, sir.
Yeah.
Uh, in the previous question, you solved by I2 dash. Where is the I2 dash?
Yes. Actually, actually in this question, the Z parameter is given as the current is this one I1 and this is the I2. Because of this port network is given, and this circuit only, this circuit, this whole circuit is this only. Okay, but the another 10 ohm resistor is adding additional in a whole circuit. So this is the 10 ohm resistor. That's why I taken as this is the I2 dash and final I2 is this one, not this one. That's why I've taken as this one is I2 dash, and the whole parameter is like that only. This is the two port network given, which one given is question, but additional 10 ohm resistance is also given. That's why I taken as a final I2 is here, not here. Okay.
Okay, sir.
Yeah. The H parameter of a two port network shown in the figure are H11 is 4 ohm, H12 is 1 ohm. No, it's not a ohm, I think. H21 is 1, H22 is 0.5. This is the gain. H12 and H21 is the gain. H2 is the admittance, and this 4 ohm is the impedance. Then you have to make a circuit according to this only. we could make a circuit. This one is given as parameter is this is the 4 1 1 0.5. Okay, same thing, additional 3 ohm resistor is adding in this question. Then is asking about when the output port is terminated in a 3 ohm resistance and 1 volt is applied at the input port here, then what is the output voltage? V2. After adding this thing, then is asking what is the output voltage? V2. Okay, let's try. First of all, you have to know about the equation of H parameter. H parameter equation between a hybrid parameter, it means it will between a V1 and I2. This is H11 I1 plus H12 V2, H21 I1 plus H22 V2. Here H12 V1 by V2 is the gain. Here H21 I2 by I1 is also gain. But V1 by I1 H11 is V1 by I1. It means this is the impedance because of voltage upon current is the impedance. But in this second case I2 by V2, H22 is the I2 by V2. It means this is the admittance, uh, reversal of the impedance because of I2 divided by V2 is the admittance, not the impedance. That's why it's given as opposite of the ohm symbol. It is also denoted as the Siemens S. Okay, let's try to draw a circuit according to these two equations. Same, the common part, negative part is common. This is the V1, this is V2, and current is I1. Here, current is I2. Okay, V1 is a combination of two part. This is the impedance because of the V1 by I1 is the H11 impedance series, and then other voltage, which one is a dependent voltage source. Then you can say this is a impedance H11 and another voltage source which will depend on the output side voltage plus minus will be H1 to V2. And second, this is the current equation. It means these are current, not voltage. Okay, this I2 is combination of two current. Two current summation, it means these two parameters are connected in parallel. Then H22 directly to multiplication is V2. It means this is the admittance. H22 is admittance directly multiplied by with the voltage. But there is a current source which one depend on the current of port 1 H21 I1. Okay, this is a circuit according to this equation. In this circuit you have to add a 1 volt of voltage source and 3 ohm resistance. Okay, let's add here up plus minus of 1 volt here and a resistance of 3 ohm. Okay, put the value of all H11 is 4 ohm, H12 is 1, it means this is the V2 only. H21 also 1, it means this is the I1 only. H22 is 0.5, opposite of O. What is the V2 in this question? Current I2 is incoming here and outgoing here. This current is flowing like that. It means this is the positive, this is the negative for this resistance, but V2 is the sign is opposite. It means V2 is minus of 3I2. Why? Because of the current is reverse. If same current is flowing like that, then the V2 is 3I2. Or voltage drop of in this resistance. But the current is opposite, that's why voltage is also negative. V2 is equal to minus of 3I2. If you find the I2, then you will get the value of V2. Okay, apply KVL here in this loop, apply KCL here in this port. By KVL, 1 volt is equal to 4I1 plus V2, because this is the 1, H12 is 1 V2, it is equal to simply V2. What is the I1 in this case? Because of here also I1 is 1 minus of V2 divided by a 4. Okay, apply KCL here. What is I2? I2 is H22 V2, H22 is 0.5, it means 0.5 V2 plus H21 is 1, means I1. We have to replace I1, 0.5 V2 plus I1 is 1 minus of V2 divided by a 4. I2 is equal, if you take a LCM in this case, this is the 2 V2 plus 1 minus of V2 divided by a 4. Then I2 is equal to 2 minus of 1 V1 plus 1 by 4, V2 by V2 plus 1 by 4. We have to put this value here. Then V2 is equal to minus of 3 1 plus V2 divided by a 4. V2 is equal to minus of 3 by 4, then minus of 3 by 4 V2, then V2 plus 3 by 4 V2 is equal to minus 3 by 4. 7 V2 by 4 is equal to minus of 3 by 4. 4 4 is cancelled out. V2 is equal to minus of 3 by 7. It will be minus of 0.428 volt. Okay. So simply you have to draw a circuit according to the given equation. If you draw the circuit, then whole thing is easy. You can simply apply KVL, KCL and you get the answer. First of all, try to find the circuit according to the equations. are all parameter: Z parameter, Y parameter, H parameter, and ABCD parameter. Mm, you see here, this is the impedance parameter equations. Circuit is looks like that. Input source, and this is the Z11, Z12, I2, a voltage source of current control voltage source. This is also current control voltage source which will control from the input side, and this is the Z22 impedance of secondary side impedance. This circuit is the Z parameter circuit, and after that, this is the Y parameter circuit. Y parameter simply because of the current. Current is sum of the two current, this current and this current, and this current is directly multiplication with the voltage. It means this is the admittance, all the admittance, and this is the current source because of the sum of the two current is there. Same thing here also output side, sum of the two current. Then this circuit is the admittance for the admittance parameter. Then the next simply Z parameter also here. ABCD parameter, you have to find a voltage source and the current source. Sorry. And next one is the H parameter. H parameter simply between the current source, a voltage source, and a current. Current is the secondary side current, not a primary side current. Then simply we have to drop first one. This one first port is H11 I1. It means this is the V1 by I1. It means is the impedance. Simply add the impedance. Then this is the voltage source because of the it will be in the voltage equation. It is in the voltage equation. Then this will is the voltage source. You write like that. This is the current source because of the this is find in the current equation. There is a current equation. That's why this is the current source. H21 I1. Then this is the admittance because of the multiplication of voltage is the admittance in the current equation is the admittance. Find then this one, then we will get the answer by simply apply the KVL KCL. Okay. Next question related to the op-amp. Op-amp is the simply a voltage control device. It looks like that. The impedance, this is the voltage, whose gain of a VD is the voltage of VD. VD is the difference, voltage difference between these two, V1 and V2. In the ideal op-amp, sorry, in ideal op-amp R is infinity. It means there is no current passing through it. No current passing through it. It means there is no current is there. It means these two voltage is the same voltage. This voltage is the same voltage. The same voltage, then there is a zero voltage difference between them. That's why the zero current is flowing through it in ideal case. And gain is the infinity in the ideal case. Okay. This is the output. It means you can say the output voltage is the gain and difference between them, AVD. VD is the difference V1 minus of V2. Okay, just simple. In the network theorem, this is the simple of them, not too complicated. It's given in the question. That's why you have to simply apply, follow this route. The input impedance of this op-amp in ideal case is infinity. It means there is no current, no current. This is also zero current flowing through it. If there is a zero current, it means all the current is passing through it, flowing through it. It means these two resistors are connected in series. And if there is not current not flowing through it, it means there is a voltage drop 0 volt, and at this terminal is the same 5 volt occurring. If this is the 5 volt, then this is the virtual short because of the voltage, the current is 0. It means there is a same voltage, these two terminal. It means you can say this voltage is also 5 volt. If this voltage is also 5 volt, then this is not voltage drop because of the zero current flowing through it. It means this is also 5 volt. The current is not flowing through any resistor, then there is no voltage drop through that in resistor. Okay. If these two resistors are connected in series and the voltage between these across this resistor is 5 volt, then what is the output voltage? Suppose let this voltage is V1, same voltage also is this one V1, and this is also V1, where V1 is equal to 5 because of the virtual short here. Then what is the V1 in this case? Suppose these two resistor right here, I draw the same circuit. This is 5 volt, 6 kilo ohm. This is also 6 kilo ohm. This is 4 kilo ohm, and this is 8 kilo ohm resistor. This is the output voltage pure. Okay, this is there is not mentioning anything in the question. It means this is the ideal op-amp. Current is 0. This current is also 0. Suppose taken as the V1, this is taken as the V2. If there is a zero current passing, there is no voltage drop. It means this voltage is same as this voltage, and because of the current is 0, it means there is a virtual short between them. That's why V1 is equal to V2 in the ideal case. Okay, it means this is zero current flowing, all the current is flowing through it only. It means these two resistors are connected in series. It means looks like that. This is ground, this is the V2, yeah, sorry, V0. If there is anything single is given, it means this is the positive terminal, and there are a negative terminal which one is directly connected to the ground. Then we have to assume like that. This is the voltage source. You can say this is the output voltage, and there are a ground like that. It means this is connected to like that. This 8 kilo ohm and 4 kilo ohm is are connected in series because of there is no current passing through. And this voltage is given as V2. It means V2 is voltage between this voltage and ground. Okay, it is this voltage V2. In series connection, what is the voltage divider? V2 is equal to total voltage, it means V naught into that resistor is 4K divided by of total resistance 8K plus 4K. What is this one? V naught 4 into 4 divided by of 12. Then V2 is equal to V naught divided by of 3. What is the V1? V1 is equal to V2.
Sorry, sir. How is 8 kilo and 4 kilo ohms in series?
Okay, okay. Because there another path is this path, na? But there is no current flowing through it because of the input impedance of ideal op amp is infinity. If there is an infinity impedance, it means there is no current.
Sir, 8 kilo ohms also, then no current is flowing. Or
No,
what is it?
this current is flowing through it like that.
Okay, okay, okay.
Then it means the current is directly
Yeah,
flowing through
got
like that.
got it, sir. Thank
Yeah,
you, thank you.
that's why these two are connected in series. Then V2 is the, if you can use a voltage divider. V2 is the total voltage into that resistor divided by total resistance. And V1 is equal to V2 barabar equal to 5 volt because of this was virtual short. That's why this is a 5. Then what is the output voltage is 3 into 5 is equal to 15 volt in this case. Simply we have to remember this one, this thing in the ideal cases because of the output voltage depending on the difference between them. If the difference between them is 0, that's why there is no current. If there is a difference, then it will flow the current and will get the output voltage. Okay. The next question. Consider the op amp circuit shown below. The value of the output voltage is same. You are asking about the output voltage.
Sir, just once again, can you scroll up?
Yeah, yeah. This one.
Yes, sir. Thank you. Thank you.
Okay. There is also V1 and V0 is given. V1 simply you can say this is the V1 looks like that. Negative terminal is grounded. Output voltage this is looks like that. This is output voltage. Ground terminal is hide in that case. This type of case circuit ground terminal is hide, but this one looks like that only the total circuit, and the all circuit is completed through it. Okay, same as okay. I draw the bigger one circuit. Then you will understand better. This is a common point or connection of V1. I write as V1 here. It is a common point. These two are connected with the same point. Okay. This current is 0 in ideal cases. This voltage is same as this voltage because of this is the virtual short. There is a 0 current flowing. It means this current is totally flowing through it, grounded, and this is a 30 kilo ohm, same resistance there. I write this is suppose VA, same voltage is also VA. And what is the VA in this case? Same two resistors are connected in series, then the voltage is half. So V1 by 2, and this is also V1. Then current is flowing through it like that, and divided into two parts. Okay, there is no current. Then you can apply KCL at this node. KCL at node VA. The current direction is this one. It means V1 minus of VA divided by of 20K is equal to this current VA minus of V naught divided by of 40K. This is 2 times, and this is 2V1 minus of 2VA is equal to VA minus of V naught. This is 2V1 minus of 3VA is equal to minus of V naught. VA is equal to V1 by 2 because of this one. This is 2V1 minus of 3 into V1 by 2 is equal to minus of V naught. This is V1 by 2 is equal to minus of V naught. Then you can say output voltage is half of input voltage minus of V1 by 2. Okay. Simply you can apply a virtual short method. I think this answer. This voltage same as this voltage. Apply. Next. Oh, okay. Consider the op-amp circuit shown below. If the input signal is a sinusoidal with peak to peak value is 8 volt, then the duty cycle of the value of the output voltage wave is equal to, assume as minus of V saturation is 0 volt. If there is a saturation is given in the circuit, it means the circuit is looks like that. V1, V2, and this is plus 2 phase saturation minus of V saturation. In practical cases is there. This op-amp is not to give a infinity gain. If there is not infinity gain, it means there is some saturation there. In this case, if V1 is greater than V2, it means the positive terminal is greater than the negative terminal voltage, then V output is equal to plus V saturation. If the same V1 is less than V2, it means negative terminal is more, negative terminal is greater, then the output voltage is minus of V saturation. In this case, minus of V saturation is 0. Suppose if this is not given, Okay, then simply I draw the circuit waveform. Sinusoidal is given, then this is omega t taken. This is the V1 and V2 I taken as this one, like that. Then what is the output? V output. When V1 is greater than V2, then output is V saturation, positive saturation. If V1 is greater than V2, here V1 is greater than V2, then this is the positive saturation plus V saturation. When V2 is greater than V1, it will, in this case, this is goes to negative saturation. This is the, can say, minus of V saturation. This is a plus of V saturation. Same here, the V2 is greater than V1. This is the minus of V saturation. In this case, this is the positive V saturation. This looks like that. Okay, but in our case, in the questions is given as minus of V saturation is 0. Minus of V saturation is given as 0. If V saturation is 0, it means this is the 0. Okay, this is looks like that. Then the question asking about then the duty cycle of the value of the output voltage wave. Duty cycle it means output voltage waveform where is the positive on and there is a where is the 0. You know about sinusoidal signal. This is sinusoidal. Total time period is the 2 pi, or you can say this is 360 degree, and the value is incoming only this part. I written as this is the theta 1, this is the theta 2. If you get the theta 1 and theta 2, then you can say duty cycle simply on time or incoming voltage time is the theta 2 minus of theta 1 divided by of total 360 degree. Here this is the duty cycle on time divided by total time. Here the angle, in terms of angle, then you can say that on angle divided by your total angle. Then you have to find the theta 1 and theta 2. What is the theta 1 and theta 2? How can you find? Is given as sinusoidal peak to peak is 8 volt. Peak to peak is 8 volt. It means from here to here is given in the question is 8 volt. Then what is this one? this voltage is 4 volt of this one. Then you can say V1 is equal to 4 sine omega t, and V2 is given and the question is 2. Then what is this point? This point is both are equal. V1 is equal to V2 is this that point. You can say at theta 1 and theta 2 also both are equal. Theta 1 and theta 2, V1 is equal to V2. For the theta 2, simply this is the 180 degree. 180 minus theta is the theta 2. Simply theta 2 is equal to 180 degree minus of theta 2. Sorry, theta 1. It means this time is the same as this time, as this angle. Okay. For V1 V2, the V1 is equal to 4 sine omega t, V2 is equal to 2, then sine omega t is equal to 2 by 4 is equal to 1 by 2. Then what is the omega t? It means same as the theta 1 is equal to sine of inverse 1 by 2. Then theta 1 is equal to sine 30 degree is equal to 1 by 2 of. Then what is theta 2? Theta is 2 is equal to 180 minus of 30 is equal to 150 degree. Then what is d2 cycle? Theta 2 minus of theta 1 divided by your total time or total angle. Sorry, this is 150 minus of 30 degree divided by your 360 degree is equal to 120 degree divided by 360 degree, 0.3333. If you want to duty cycle in percentage, this will be 33.33%. Okay.
Sir, what does duty cycle refers?
Duty cycle, it means for what time period output voltage you get will get, or time period is it will be not getting. It means this is the percentage of output voltage getting in total time. The duty cycle. The output voltage in one cycle. This is the one cycle from here to here. This is the 360 degree. Because of the sinusoidal signal is coming to the time period is 2 pi, it means 360 degree. In 360 degree, the output voltage is only between the theta 1 and theta 2. Then theta 2 minus of theta 1 is the time where we will get the output voltage. That's one is the duty cycle. Okay.
Okay, sir.
This type of circuit you can use to generate a pulse PWM for any circuit like to draw a MOSFET or IGBT or switches. This type of circuit is applied like in a converter. If you know about the converter, there is a voltage controlled by the duty cycle. If this duty cycle is increase, then you'll get the average output voltage also. Output voltage will be controlled by the duty cycle. If you increase the duty cycle, then output voltage is more. If you decrease the duty cycle, output voltage is less. Suppose in this case, okay, what is the output voltage? Average output voltage. In this case, V output average is equal to area of this one. Area of this one is V saturation into how time period is there, 150 degree divided by a total degree. You can say the maximum voltage, it will be 0.33 V saturation. Suppose if you increase the duty cycle, okay, 152, suppose 200 degree, then that time what is the output voltage? V saturation into 200 divided by a 360. In this case, we will get the 0.555 V saturation. It means the output voltage will be increased, the duty cycle will increased. How, why increase? Simply you have to reference voltage V2, you have to decrease this one. You decrease the here, then duty cycle will be increased. And this control circuit is used to control the output voltage of the any converter, DC-DC converter. This is looks like the pulse modulation, pulse width modulation.
Sir, if minus V sat was there, then duty cycle would be, sir, 1, sir.
This time the output voltage is 0 because of the average is the 0 na.
Okay.
That case. This one, if output voltage is coming, that means the all the duty cycle is 100%. Okay, next one. Consider the circuit shown below. The resistance Rin as seen by the voltage source is. You have to find the internal resistance, input resistance. Input resistance, you know, Vin is given. It means you have to find I. Then Rin, you can say Rin is equal to Vin divided by of In. Same you can apply the also short phenomena. This is current is 0, means there is no current. This voltage is directly connected to this voltage. This current is 0. Then this voltage is V in. Then this voltage is also V in because of virtual short. We can apply KCL here at node A, at node B, KCL at node A. This is 0, current is flowing like that. In here you can take the current is flowing like that or like that. For a reference, I have taken like that. This is 0 because of the ground voltage, 0 minus of this voltage V in divided by of 10K. 1 mega ohm I rated as this one is the 1000 kilo ohm. Because of the all parameters in kilo ohm, all resistances in kilo ohm, that's why I rated as this one also in kilo ohm. 10 is equal to V in minus of V naught, this current is divided by of 100K. This is minus of 10 V in is equal to V in minus of V naught. Then you can say V naught is equal to 11 V in. Same, apply KCL at node B. Current flowing like that. I in is equal to, you can say, V in minus of V naught divided by of 1000 K resistance. 1000 I in is equal to V in minus of 11 V in. Place of V naught you can replace at 11 V in. 1000 I in is equal to minus of 10 V in. Then what is the V in by I in is equal to minus of 1000 divided by 10 is equal to minus of 100 K. Oh. Okay. Sorry. Next question. Consider a circuit shown below, assuming the op-amp to be ideal and the value of output voltage. We have to find the output voltage in this case. Same thing you can apply. This current is 0. This current is also 0. It means there is no current flowing through it. No meaning of this resistance. This is the 5 volt. This is also same 5 volt. And what is the output voltage? You have to apply KVL in this loop. This is 5 volt. Somewhere is the ground is there. Apply like that. This is the minus of 5 plus 2 plus 6K. Current is 0 plus V naught divided by equal to 0. And this is the minus 3 plus V naught is equal to 0. 3 volt. Okay, if you take this is the source of virtual short, then you can start the KVL from this one to this one. This resistors have no meaning because of there is no current. Okay. The next question, for the op-amp circuit shown below, the output saturation voltage are plus minus of 15 volt. Then the upper and lower threshold voltages for the circuit are. In this case, the threshold voltage is given as plus minus 15 volt. It means this positive voltage is plus 15 volt and negative voltage is minus 15 volt. V in is here apply at this point. You have to find this voltage. Okay, some circuit I want to draw here. This is plus and this is negative. 3 volt, 5 kilo V out. Yes, saturation is given. It means this is the 15 volt. This is the minus of 15 volt. Okay. Okay. This current is 0. This is current is 0, not going, flowing. This is voltage V1 suppose. Then this whole circuit is connected in series. And what is the V1? This case because of you have to need of V1 here also. You can apply KCL. Then this current is equal to this current V out minus of V1 divided by voltage drop divided by resistance 10K is equal to V1 minus of 3 volt divided by of 5K. This is V out minus of V1 is equal to 2V1 minus of 6. Then V1 is equal to V out plus 6 divided by of 3. Okay. Same thing, if V in is greater than V1, then what is the output voltage? It means negative terminal is greater, negative terminal is more, then the output voltage is negative minus of 15 volt. Okay. If V in is less than V1, it means the positive terminal is greater than. Then V out is equal to plus 15 volt. Then you can place here what is the threshold voltage of V1 for this one. 15 was minus of 15 output plus 6 divided by of 3. This is the minus of 3 volt. In this case V1 is plus 15 plus 6 divided by of 3 is equal to is a plus 7 volt. And threshold is 7 volt and minus of 3 volt. Okay. Then this is the answer. Next, I'm assuming the op-amp to be ideal, then the value of output voltage in this case.
Sorry, sir, just 2 seconds. Can you
Yes, yes.
5 seconds?
Okay.
Thank you, sir.
Oh, welcome. Simply, you have to compare these two voltages, positive voltage and
Sir,
negative voltage. Yes.
I mixed up the question number 8 and 9. Can I see it again?
This is 9,
And 8.
8.
Yes,
This one.
yes, sir. Sir, what is happened in the question in in the answer of the question number 8?
Actually, in this question is asking about the resistance R in as seen by the voltage source is. It means here asking the input resistance. Input resistance, you know, resistance simply V in divided by F I in. Because of arrow is given as this type, this means I have taken as the direction in this case also same I in. Then you have to find V in and divide by F I in. Because of the this current is 0 the op amp, then because of the virtual short, this voltage V in directly connected here, then this voltage is also V in at node 1. Then you have to apply a KCL. It means this current is equal to this current. This current is 0 minus of V in divided by F10, voltage difference divided by resistance. Same thing in output side is V in minus of V output divided by F, this resistance 100. In this case, we will get the value of output voltage as 11 V in. Same thing we have to apply KCL at node B. It means this here is I in. I in is equal to this voltage minus of this voltage V in. This voltage V in minus of output voltage divided by of this resistor 1000 K. In this case, we will get the value of I in terms of V in. Then you have to replace the output voltage as 11 V in, and we will get the value of V in divided by I in is equal to minus of 100 kilo. It's fine.
Yes, sir.
Okay. Okay. In this case, we have to find the output voltage. Because this is the sorted here connected. Okay. This voltage is given as V1, V2. In terms of V1, V2, we have to find the output voltage. This voltage V1, V2, this is 0. This is also 0 current. It means this is sorted to each other. This is voltage V2. You have to apply a KCL at node V2. This current is incoming and these two current is outgoing. Incoming current is equal to outgoing current V1 minus of V2 divided by R is equal to this current is V2 by 2R plus V2 minus of V output divided by of 3R. RR will be cancelled out. V1 is equal V1 minus of V2 is equal to V2 by 2 plus V2 minus of V0 by 3. I have to take LCM as 6. This is 3V2 plus 2V2 minus of 2 V0. This will be V1 minus of V2. This is 6V1 minus of 6V2 is equal to 3 to 5V2 minus of 2 V0. This is minus of 2 V0 is equal to, this is transferred to the left side, then 5 minus of 6 is equal to minus of 11 V2 plus of 6 V1. Minus you can multiply minus 2 divided by here, then this will be minus of 3 V1 plus 11 by 2 V2. Okay. So simply you can apply KCL at node this at this node because of this two voltages are same. Then incoming current is this one, and this current is divided into two part, this part and this part. incoming current is voltage difference between them 2 is V1 minus of V2 divided by this resistor is equal to this current is V2 minus of 0, this is the ground, divided by 2R, then V2 minus of V0 divided by 3R. Then you have to solve this equation or you get the output voltage in terms of V1 and V2. Okay, everyone. Okay, I want to stop here for the today class. Thanks to all to join.
Yeah. Thank you, sir.